and welcome. In this tutorial, we will build a concentric texture warping effect in Max. Before we start, let's quickly go over what we're trying to achieve here. The main idea is to rotate an image around an anchor point. But before rotating it, we will divide it into discrete rings, and then each of those rings will rotate at a slightly different speed. We then feed the result back into the algorithm, and this makes the image iteratively distort more and more with each step. This tutorial consists of 3 parts. In the first one, we will rotate the texture. In the second one, we will build the rotation mask, which will then create the discrete rings. And in the third one, we will implement the feedback. I will start with a Jit world and a Jit.p window. First of all, let's import an image and turn it into a texture. So in order to do this, we can create a Jit matrix, then use the message import movie followed by a bang. Then we need to create a texture, dimensions full HD for now. Also, let's say a depth 0, so it doesn't change no matter what image is coming in. And when working with feedback, I always like to use the type float32. Okay, then let's copy this P window, import a picture. Okay, this seems to be working. So in order to rotate this, first, I think we need to bang this one every frame. So let's create a Jit bang object. And then we can, I guess I can just delete this and plug this directly in here. Align this, and then we can continue by creating a Jit.gl.pix Codebox. And the rotation will pretty much live in here. For a rotation, first we need an anchor point to rotate it around. So if you want to rotate around the center, this anchor point will be 0.5, 0.5. So it's 2D vector representing the X and Y position. If we want to rotate around this edge up here, the anchor would be 0, 0. Down here would be 1, 1. Okay, so I will create a parameter so we can access it from outside the code box. So let's call this one for anchor. Then let's initialize this. Okay, in order to rotate an image, we first need to create UV coordinates. So I will just say UV equals norm. So these are just the normalized coordinates. Let's have a quick look. So UV. And these are now Cartesian coordinates, so they're ranging from 0 to 1 on the x-axis and from 0 to 1 on the y-axis. And in order to rotate an image, I want to turn these Cartesian coordinates into polar coordinates, which are then represented by an angle and a radius. So in order to do this, we can use the function or the operator car to pol. This takes x and y as an input, so uv.x and uv.y. And as an output, we get the radius and the angle. And as we're getting 2 outputs here, we can write it like so. So this will set our radius and our angle. Then we need to translate them back into polar coordinates, which is then again x and y. Translate back into Cartesian coordinates. So for that we can use pol to car. And as an input, we then again set the radius and the angle. And then, yeah, we have to reassign this and say uv equals a vector with x and y. So you might ask yourself, why are we doing it in this convoluted way? Because at the end, we're just getting this one back we started with. But the cool thing about this is that now we have the explicit angle here, we can change this angle. So if I'm just creating a parameter, call this one angle, we can then add this one in here. So I want the input to be in degrees, but this Paul to car needs radians. So I can just use the operator radians, input the angle here, and then I get an error. What's the error? Radians is not defined. Oh, because apparently I spelled it wrong. Okay, so now we can use this angle here, and you can see that we're turning this or rotating this. But as you can see, we're always rotating it around this point here. But we specifically created this anchor in order for us to rotate the image around this point. So we first have to shift the whole image or the whole UV coordinates so that this point is essentially at our anchor. Then we can rotate it and then we can shift it back. So in order to do this, we first need to subtract the anchor here. And then we can add it back in here. So now if I'm rotating it, you can see that I'm rotating it around the center. If I'm changing this, I don't know, to something like that, then you can see we're rotating it around this point. And in order to apply this rotation, we can just say sample in 1 UV. And then you can see that we're rotating this image. So far, so good. I'm doing a deeper explanation of this in my Jit.gl.pix Codebox intro or fundamental technique videos. I will put them into the description. But as you can see, the image weirdly distorts when we're rotating it because we also have to take the aspect ratio into account. And in order to do this, we can create a new variable, call this one ratio. And this one is just a vector. And for the x component, we're saying dimension of x divided by dimension of y. And for y, we can just take 1. And then in order to take this into account, we can first, I'm putting this down here because we now need it. So we multiply this whole thing by the ratio. And then here we have to divide the whole thing by the ratio again. And now you can see that we're not distorting anymore. We're just rotating around this point. Okay, I think that's it for part 1. Now coming to part 2. So we're creating the rotation mask now. So in order to do this, we will first create a circle. I'm just wondering where to put this. Yeah, let's put it down here. Okay, so this belongs together. Then, yeah, let's first start with creating a circle. So let's say circle equals length of our normalized, or of the signed normalized coordinates ranging from -1 to 1. And then we can temporarily output this one here. So this is the circle that we created, but you can now see that when we're using signed normalized coordinates, so ranging from -1 to 1, the circle is in the center, but we want the center of the circle to be dependent on our anchor point. So in order to do this, we can say, you know what? I will first create a variable and call this one circle UV. So this is a bit cleaner. And the circle UV will be our normalized coordinates and, norm. And we will subtract our anchor point from them. And then we can say our circ is then just the length of our circle UV. But as you can see here, the circle is also distorted because our texture is not a square. So in order to get rid of this distortion, we can also just multiply this by our ratio. And now it's a regular circle. Okay, in order to get the rotation mask, so these discrete rings, I will first create a parameter and call this one num_c for the number of circles we want, and just set this to 5 for now. So I want to turn this gradient into discrete steps. In order to do this, we can quantize this range from 0 to 1. Let's create a new variable, call this one rm for rotational mask, and this one is, so first, so this one ranges from 0 to 1, so we first multiply this by the number of circles. So now this ranges from 0 to 5. So let's take a look at this. In order to get discrete steps, we can just use the floor function, which will get rid of all the decimal places. But now 0 to 5 is not visible for us because we can just see 0, and then 1, 2, 3 is just white. And in order to make this visible again, we can say that we're dividing it by 5 again, and now we can see our 5 discrete steps. So what we now want to do is control the angle with those rings. So the brighter a ring, the faster we want to rotate. And this is pretty straightforward, I'd say, because if we multiply our incoming angle by just this mask, then in the center it won't turn. Here it will start turning, and the brighter this gets, the higher the value and the faster we will turn. So in order to do this, we could, okay, first I will take this whole block and put it here. Then instead of using this angle variable here, I will rename this one time, because we'll use a jit.time as an input for this one. Then here we can create our angle again. So angle will then be the time variable multiplied by the rotational mask. Okay, and then we can get rid of this. And now we can access the time variable from the outside. And if I'm changing this, you can see that we are rotating in discrete rings, and each of them is rotating at a slightly different speed. And if I'm changing the number of rings to something like 25, we get this. What we could also do is, instead of doing the discrete rings, we could just say rm equals our circle, and then it will rotate around continuously. But yeah, depending on what effect you want to achieve, the other one might be better. What we can also apply is, so we could multiply this whole thing by the circle. Because remember, the circle looks like this. And when we multiply the whole thing by the circle, we will get kind of a depth effect, because here it will be very bright and here it will get darker, giving it a kind of 3D effect, as if the whole thing is getting sucked into this hole right here. So in order to do this, we can just multiply the whole thing by circ, and then, yeah, you can see it looks like this. Okay, I think that's it for part 2. Coming now to the part that makes this effect really unique, we will use a feedback loop. So the idea is we send in this picture, then we will rotate it, then we will send the rotated picture in here again, rotate it again, but this time with a different anchor, so rotating it around a different point. And this will create this kind of weird distorted vortex look. Okay, in order to do this, first I will create another outlet here. And this will just be, I don't want this shadow applied to the feedback. So maybe let's just create another variable, call this one color, and color is then just what we're getting out here. Then outlet 1 is color multiplied by the circle in order to get this dark spot here. And the second outlet is just the color for our feedback. Okay. Then I will make some space. Okay, what do we need now? So first, let's put this one down here. Okay, first I will use a zl.reg object. So this takes a list in the right outlet, and when we send a bang or another list, it will output this immediately. So the list in our case is the texture, the feedback texture we're getting. So this is the one from the second outlet. So we can plug this in here. Do something like this. Then in this outlet, we can just put this matrix. So every time we change the matrix, of course, we want this to go through. And then what do we want? So this texture will constantly be sent back in, but it won't move past this object unless we bang this here. So first, let's create a system to get a random anchor point. Oh, sorry, didn't mean to do that. So in order to do this, we can use a random object. Then we can multiply this by 0.01. So the output will be a number between 0 and 1. Because remember, 0 would be up here and 1 would be down here. Then we need 2 values. So we could use an Uzi object 2. So every time we bang this, this will give us 2 random values. And then we have to group them. So let's say zl group, so that we create a list out of them. So this would look something like this. And then we can say prepend anchor to change, maybe this needs to go up here, to change our anchor. Or you know what, I will create a dummy inlet for this one. So I have a second inlet here. So you can see we're creating random anchor points now. Then what we also have to do is, I will copy this one, call this one time. Then we can use a jit.time object. Oh, where is it? Oh, sorry. Plug this in here. But you can see this is turning very slowly. Because here we're working with degrees. We can crank up the speed of this one. I don't know, let's try something like 50. Yeah, that's much better. Okay, and then what do we actually want? We want to bang this one to get a new anchor. We also want to reset this one. And we also want to bang what's coming out here. So let's say trigger bang, bang, bang. For this one, we set the reset message here. Then we create a new anchor here. And then we can bang this here. Okay, let's see if this worked. And also maybe let's create a way to reset the whole thing. So maybe trigger bang bang. So banging this one again, resetting the timer again. So it starts from scratch. Okay. Okay, this works. Resetting this one. Okay, and theoretically, if I'm banging this one now, the anchor of rotation moved. But we're not resetting the whole thing. All the previous rotations stay where they were. I mean, the effect, I think, is even... Or let's... where is it? num_c. So if I'm just using 5, I guess the effect would be even stronger. Okay, so this is a bit bright here, so maybe let's divide our circle by the square root of 2, because I think this is the maximum. Yeah, that's better. Yeah, and as I showed you before, we could also say that the rotation mask is just our circle. Then we don't have these discrete steps in here. And then we get this almost 3D looking space distortion. Let's maybe use another picture, reset this. Yeah. Something like 25. We could also randomize this and say we're sending another bang in here and then use prepend number of circles, or maybe it should be called number of rings. And then say, okay, a random number between 0 and 50. Yeah. Okay, so that's it for part 3 and for this video. I hope you found this useful, and thank you for watching.